All right, I'm Declan Fortune, and I'm the group leader for Experiment 4, covering the Rankine cycle. So, just very briefly, the goals of the experiment is one, to understand and safely perform the operation of the Rankine cycle. We also want to be able to calculate the thermal efficiency at steady state conditions. So we want to operate within the bounds of 0.2 amps, 6.0 volts, and we want to maintain a boiler pressure of around 110 psi. And ultimately, we want to be able to carry out calculations and be able to convey those results in the following presentation. So for the ideal Rankine cycle, there's really four main components, which is the feed water pump here, the steam generator, the steam turbine, and the condenser. And so there's a lot more complex Rankine cycles that you can develop, but this is the ideal circumstance. So a bit of background and theory. The Rankine cycle is a closed-loop cycle consisting of like four main steps. As Spencer stated earlier, in the lab, it's not exactly closed-loop, but in terms of background and theory, we'll consider it as a closed-loop cycle. So to cover the four steps, water is pumped from the pump into the boiler, where the water is heated into superheated steam, and then that steam is then funneled into, through piping, it's funneled into a turbine to where the pressure from the steam is converted into work, and then the residual steam that's now at a lower pressure is then pumped in or flowed into a compressor where the residual steam is then converted into water. And typically, not all the water is conserved, so you will have to have like water input into the system. Oh, and additional facts, 90% of the electricity utilizes the Rankine cycle, and then it's also known as the vapor power cycle. So to go more in depth with the processes, as you can see, there's different steps here. So going from process 1 to 2, we go through the pump where the liquid water that comes through the condenser or is input into the system is pressurized, and then that flows into process 2-3, where the water enters the boiler and turns into superheated steam, and then that goes into process 3-4, like I covered earlier, where the steam flows into the condenser and it goes from high pressure to low pressure as you convert that that energy into work. And then process 4-1 is where the low pressure steam is condensed and the cycle begins again. So to talk about the energy balance of the system, so for the whole cycle, it's a summation of processes 1 all the way through to 4. You can see the work of the pump is calculated by taking the entropy at point 2 minus the entropy at point 1. And the QA here, as I have the heat added by the boiler into the water, is calculated by the entropy at point 3 minus point 2. And then the turbine work is calculated by taking the entropy at point 3 minus the entropy at point 4. And then the heat that's rejected by the compressor is calculated by the entropy at point 4 minus point 1. And then one of our main objectives is to determine the total efficiency of the Rankine cycle that we are working with. So you take the total work of the cycle divided by the total heat that's been added into the system, and you can see the equation for the entropies, but to not be redundant, I won't say those. So a couple things to consider. What I talked about earlier was for an ideal Rankine cycle, and so what we'll be working with in the lab, there's extraneous factors that will, influence our results, and we will have to, acclimate to make up for those. So the two irreversibilities here are fluid friction and heat loss. So the pump will have to run at higher pressures to make up for the fluid friction going through the pipes and different components, and then the heat loss due to steam, you will have to input more heat into the boiler itself. And then, yeah, that allows us to kind of use our steam tables to determine different values that are going through the cycle. And lastly, this is the apparatus that we will be using within the lab. So you can see that our fuel source is propane, which is input into the boiler, where the water will go through and will turn into superheated steam, which here you can see the steam turbine, where the superheated steam will go through, spin the turbine, generating electricity and then, or power, and then that flows back into our condenser on the left here, which again cools down that superheated steam, turning it into water, and then that is input back into the cycle. And then we also have our computer program that allows us to computate our results. And then here are my references, and do you have any questions?
Any question? Congratulations. So yes, MCs.